up because it's time to go beast mode.
AB 2015 FRQ number 1. 1A. How many cubic feet of rainwater flow into the pipe during the 8-hour interval from hour 0 to hour 8? Even though they tell you that there are 30 cubic feet of water in the pipe at time 0, and even though they give you the function or the rate modeled at d of t, which is basically a negative rate, they're asking for how much rainwater flows into the pipe during the 8-hour time interval. So with the information, all you have to do is integral from 0 to 8 of r of t. You don't have to do plus 30, and you don't have to do minus d of t. Just integral from 0 to 8, which is 0 to 8 hours of r of t. And the reason why you're doing r of t is because technically, since that is the rate at which water is flowing to the pipe, it's the derivative function of the actual amount of water going to the amount of water in the pipe. Meaning that this is that area under the curve which helps you find how much amount of water flows into, and that total amount from hour 0 to hour 8. So doing so on your calculator, you would press math 9, and that's how you get your integral. You set your integral from 0 to 8, 0 to 8, and then instead of typing r of t, you're going to type your actual function, which is 20 sine of t squared over 35. And the reason why you don't have to when you're showing your work on the AP test is because readers know that r of t already is 20 sine of t squared over 35. So this is a great way to save time, especially if you have long functions and you don't need to write everything out like d of t. So by doing so, you should get this equals around 76.570 cubic feet of water, and you say that of water flows in. Alright, so moving on to B. Is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? And give a reason for your answer. So if we know if you know what f of x and f prime of x looks like, for example, if you have f of x looking like this, f prime of x will look something like this. And this is because for where f of x is increasing, f prime of x happens to be positive. And where f of x is decreasing, so this latter half after p, you see that after this point p on f prime of x is actually negative. So having this in mind and knowing how f prime of x relates to f of x, if they're asking for the amount of water in the pipe, we know that that is the antiderivative, or just the function of the amount of water in the pipe, where r of t and d of t are the rates at which the amount of water in the pipe is flowing. So this technically could be the amount of water, and this is r of t minus d of t. So knowing what I just said, where increasing equals positive on the f prime of x function and decreasing on f of x equals, f prime of x, where f prime of x is negative, we can find that if we plug in r of 3 minus d of 3, whether that number is positive or negative. If it is positive, let's say right here, this is where time equals 3. If it is positive, then on your function where it represents the amount of water, it'll show that it'll be increasing. So if we plug in r of 3 minus d of 3, you should get negative 0.313, which is a negative number. So now we know that the amount of water in the pipe is actually decreasing at t equals 3 hours. So really all you have to show for your work is r of 3 minus d of 3 equals this number, which is negative 0.313, and then you show that this number is less than 0, therefore the amount of water is decreasing. All right, so moving on to C, at what time from time 0 hours to 8 hours is the amount of water in the pipe at a minimum? And when they ask for a minimum or a maximum, they're pretty much asking you to use EVT. And EVT states that from a closed interval A to B, there's always going to be a global max and a global min. So for example, it could look something like this, where you have a global min here and a global max here, or it could look something like this, where from A to B, your min is not A or B, and your max is not A or B either. But sometimes it can be. So with this information in mind, you're basically testing not only for critical points, and for example, a critical point would be here because this is where the derivative is equal to 0 because there's a horizontal asymptote here, or a horizontal like tangent line, I mean. But you also need to test for the endpoints. So you're testing for both of these. So the best way to do these types of problems are actually just making a table for time and then your y function, which is just amount of water. And I'm just writing that out just for simplicity. So knowing that we have to test the endpoints, you're testing these points, but then you need to find the critical points. So since they already give you the derivative functions or the rate functions r of t and d of t, all you have to do is figure out when that equals 0. And to do that, all you have to do is go into your calculator, press y equals, and this is where you're going to make your equation. And then after you make your equation, you find where the graph from, and you set your window to 0 of 8 because that's where t is measured in hours for the problem, and you find when that equals 0. So when t equals 0, you should get 3.271. So we can write that here. So now with all this information, you're basically plugging in all these values of t into the integral to find the total number of water at that specific point to see whether it is a minimum or a maximum. And basically from this chart, you're finding which amount of water or what value amount of water corresponding with the value t is at its lowest. And a common mistake that students make is they forget to do 30 plus this whole integral. And the reason why you're doing 30 plus that integral is because they say that there are 30 cubic feet of water in the pipe at time equals 0. So doing so, you get, they tell you that since at t equals 0, there's 30 cubic feet of 30 cubic feet of water. At time 0, there's 30 for the amount of water. And then if you're plugging in t equals 3.271 hours, you're going to get 27.964 for your amount of water. And then if you plug in 8 into that integral, you're getting, or that integral plus 30, you're getting 48 plus 48.543. So as you guys can see here, our lowest value is actually at t equals 3.271, which gives you the lowest amount of water, which is 27.964. So to justify, you could say something like due to EVT, or make sure you guys state EVT. You say because t at 3.271 is at the lowest water amount, that is the minimum. Alright, so moving on to D. The pipe can hold 50 cubic feet of water before overflowing for times after 8 hours. Water continues to flow in and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve an equation involving one or more integrals that gives a time W when the pipe will begin to overflow. So they tell us that 50 cubic feet of water is when the pipe will start overflowing. So we'll write 50 equals, and this is for D. So 50 equals, and then they tell you that there's some time t after 8 hours where the water continues to flow in and out, but we don't know. We're trying to solve for this time w when the water will be at 50 cubic feet, because that means it'll be overflowing. So you're writing integral from 0 to w of r of t minus d of t, because it's the integral of the rates that water continues to flow in, which is r of t, and flow out, which is d of t. And then last thing, make sure to add plus 30, because that is technically your initial value that they tell you right here, where there are 30 cubic feet of water in the pipe at time 0. So this should be your equation. Something short, and you don't have to solve it because they tell you not to solve it. So that is the 2015 AP Calculus FRQ for number 1, a rates problem.